Hi class, here is just a quick video for those of you that missed our final lecture on Unit 6. And in this video we're going to talk about hydrogen fuel cells and then finish up the chapter with chapter 13 with the discussion of sustainability and energy conservation. So hydrogen fuel cells are one of the substitutes for traditional combustion engine in cars, and they're pretty promising technology that's been around for a while, but it hasn't been fully implemented on a large scale. But so anyway, the way it works is that pretty much it's like a battery, and you can see here this is kind of a close-up of the reaction that's going on within the car here. Basically what's going on in this fuel stack. So here's a picture of a fuel stack, and if you remember, electrons, the flow of electrons is essentially what electricity is. Whether you're generating that in a generator, or if you're a photovoltaic and you have a flow of electrons that are released from the silicon. So here the electrons are derived from hydrogen. So okay, so hydrogen enters in this fuel stack, and there's this top layer, this reaction layer, that's made of a certain element. Often it's actually platinum powder. And what happens is the hydrogen, where'd my mouse go? There it is. The hydrogen splits. So protons go through the membrane. They're attracted to this layer, which is has a negative charge. The positive protons are attracted to it. The electrons travel here. They don't want to go through the layer because this is negative on this side, so they stay up here, and the flow comes, and basically there is some sort of device that actually captures that energy and transfers it into electricity that the car can then use. Okay, so then the electrons travel across here, and they come back and meet up with the protons from the hydrogen originally, and they then combine with oxygen from the air to create water as a byproduct. Okay, so you can see here that the steps here, hydrogen molecules split, protons move across this membrane, electrons take an alternate route, which is the electric current, and then the oxygen molecule then combine with the protons to form water. Okay, so you get hydrogen from the tank, so you can see the hydrogen cylinders here that are required to provide the hydrogen, and oxygen from the air. Those then combine to make water, and the electric current is then used to run the engine, and you can see this Ruby car there. So what are the positives and the negatives of hydrogen as a fuel source? Well, as you can see here, you need the hydrogen as a fuel, which you need to derive from somewhere. So that gets to disadvantages. I'm getting ahead of myself. For the advantages, you have very high energy density here. You can do a lot with a little bit of fuel. There's also no greenhouse gases and few other pollutants. You basically have water as a byproduct. And these engines that run on hydrogen fuel are three times more efficient than a combustion engine. So combustion engines are 20% efficient, and hydrogen fuel based engines are 60% efficient. So that's good. So the problem with hydrogen fuel is that it needs special storage. It's explosive and it's volatile. So volatile meaning that it's a gas, so it evaporates and goes into the air really easily. So you need to store it in a special way. And you also need the hydrogen as a fuel. And so this is not easy to get. Hydrogen reacts pretty much with everything, so in order to isolate it, you need to input electricity to do something. You might have heard of electrolysis before, which is essentially the splitting of water into oxygen and hydrogen, and you can use electricity to do that. Hopefully that would be electricity from a renewable source, or you can also use natural gas, which, as you remember, hopefully is CH4, and you can isolate that hydrogen there, but again, you're using natural gas. So if you can do electrolysis of splitting water using a renewable electricity source, that's kind of the ideal situation. And it's also really expensive. So a new the cars that you could get, there's actually, I think, a Honda coming out in 2013 that's about $50,000 fuel cell car, which is not very cheap. Okay, so that's pretty much hydrogen, hydrogen fuel, and then we jump right into how can we use less energy? So, this talk of renewables and the potential in the future, which, we're just going to have to keep using more and more of if we want any reliable and kind of long-lasting energy sources. So we basically need to conserve energy and use energy more efficiently. So, looking at these two different things, you can reduce your amount of energy use by using fluorescent light bulbs, not using cars as much, public transportation more. And then there are also a lot of efficient devices. So energy efficiency is something that companies can really undertake, and they have been, and consumers want efficient appliances because it doesn't cost as much money to power them. So it's really a win-win for everybody. And our technology is allowing us to have much more efficient electronics now, so that's good. And then here's just a nice diagram from my old book of how we can save energy at home. So I would just read this over so you have a few examples of you have a few examples of ways that you can save energy at home, and that you're also familiar with all of these techniques, whether it's using full loads in the washer and dryer as opposed to partial loads, installing water-saving faucets, using insulation, unplugging appliances, setting the thermostat at a certain temperature, all that kind of stuff. So just read over that so you're familiar with it. And then also using sustainable designs to reduce energy use. We talked about this before with passive heating in houses, and having it so, if you're in an area that gets cold in the winter, you want to have proper orientation. If you're in the northern hemisphere, to the south, so you can maximize your exposure to the sun. Maybe having a tree here, so in the summer it has leaves and it blocks the sun so it doesn't get too hot. You want adequate insulation, sealing the cracks, that sort of thing. And there's a term called thermal inertia, which basically, it says in the book that it's this ability of a material to retain heat or cold. So it's basically material, and concrete is a good example, that doesn't change temperature too quickly. So it in and of itself is a good insulator, and yeah, it'll save you energy where you are able to kind of retain heat in a building with using a material that has a high ability to retain heat. And some buildings in our area that are good examples of sustainable design. This you may recall or recognize as the California Academy of Sciences. Very cool design with green roof and all these solar tubes like we have that provide solar lighting. And then this, of course, is our very own Homer building. Again, see the solar tubes and the green roof. Okay, and now here's a discussion of peak demand. Okay, so peak demand is essentially the moment during the day when electricity is being used in the greatest amount. So here is a graph, and this graph is faulty. It doesn't have a y-axis label there, but this is what, let's say, a power plant, the demand for a power plant would have during the course of a day. So this might be the demand for an entire town and what the entire town is using over the course of the day. And you can see that the peak demand here is when it obviously gets the highest. So maybe, in the afternoon when people are coming home from work and they're starting to cook dinner or something. And the important thing is that the power company, the power plant needs to provide enough electricity to the town so that they can meet that peak demand, so that they basically are able to have electricity generation at this point. Because if they don't, if the peak demand goes above the point that the power plant can provide, you get blackouts, power outages. And so this occurs in the United States, occurs everywhere, where you basically have people as a cumulative area in a town or a city, they are demanding too much electricity and the power plant can't keep up, so there's a blackout. So how can we reduce this peak demand? There are a couple of tricks that are already in place. There's something called variable price structure, where customers pay less to use energy when the demand is lowest and more during peak demand. So basically this gives incentive for people to use appliances when the demand is low. So for something like, let's say you're washing dishes in a dishwasher or doing laundry, if it doesn't matter to you when you want to do this, you're obviously going to want to do it when it's cheapest. And that is going to be cheapest when the demand is lowest. So this really kind of evens out the use over the course of the day, because a lot of people, are going to want to save money. So they'll do certain things with electrical appliances when the demand is lower. So that's a really smart way of doing it. And then there's also something called a tiered rate system, where you're basically charged more per kilowatt hour as you use more electricity. So customers pay at a low rate for the first increment of electricity they use and pay higher rates as their use goes up. So essentially, the more electricity you use, the more you're paying per kilowatt hour. So it really kind of punishes you for using more electricity. And then these practices, of course, encourage people to reduce the amount of energy they use. Always works with money. People don't want to pay more and always want to save. And then the last slide here, or second to last slide, I guess, is with the discussion of the smart grid. So the smart grid is essentially coordinating our energy use over an entire town with the availability. So you can just look through this, and I like, this diagram. It really shows what's going on here. You can have appliances that are quote-unquote smart appliances that actually can shut off on their own if you get too much use across the entire grid. So all of the different houses and power plants and offices and stuff that are all connected and use energy from different sources. The appliances can also be shifted to work during off-peak times to save the money of the household. You can also get different electricity supplies, whether it's solar panels or wind farms, that come on to the grid as it's needed. So you're using it during the peak times, or they can be stored, where's my mouse? Energy generated at off-peak times can be stored in batteries for later use. So just kind of a way for the entire grid to prevent power outages if the system gets more overloaded. And you can kind of isolate parts of the grid. Let's say if there's this area here that's struck by lightning, or there's some other disturbance like a flood, you can kind of isolate that area. So we used an analogy in class of Christmas lights, and how Christmas lights used to be that if one bulb went out, the entire chain went out, and you obviously don't want that in a power grid. So now, like Christmas lights, if you have just one light goes out or one area goes out, the rest of the area is still intact. So that's a smart way of doing it too. Okay, and then the last slide I have here, and this is in your book. It is just comparing all the renewable energy sources, advantages, disadvantages, the different emissions, and then the costs. So go in your book and check this out. Maybe make a table for yourself. There is, you should note that there is one energy resource that's missing. I'm kind of surprised that they don't include it here, but if you look at all the different ones, they have the different solar energy ones, and you have photovoltaics, you have solar water heating. They don't include on this table solar thermal electric, that's concentrated solar thermal electric with all the mirrors. So just be aware of that. This table is not perfect, and you definitely need to know that too. Alright, I hope you have a great weekend, and go Niners. See you in class. Bye-bye.